It's Hwk14 question 6. We got an equation y equals 3x squared minus 4x plus 2. We're told that the line L1 is normal to the curve C at the point P11. And then part A is asking us to show that L1 has the equation x plus 2y minus 3. Now in order to generate an equation we need to find out what what we need really is this, and I refer to it as the equation generator. So this is your y coordinate, m is your gradient, and x1 is your x coordinate. So what we need is the y coordinate, the x coordinate which we got 1 1, but we need to find the gradient of the normal. In order to find the gradient we're going to have to differentiate y with respect to x. So we differentiate y with respect to x, now 6x minus 4. Of course we want the gradient at that specific point, so we're at point P, which is 1 1, dy of dx is 6, and then our x coordinate's 1 minus 4, which of course will give us 2. Now the thing is, this is effectively the gradient of the tangent at the curve. So in order to get the gradient normal, it's a negative reciprocal. Yeah, negative reciprocal of the tangent. So in this case m will equal minus a half. So this is good because now we got we got y1, we got x, and we got m. So we're just going to plug it all in and we should have y minus 1 will equal minus a half x minus 1. Okay. So obviously we want to simplify and like rearrange it, etc. So if we times everything by 2, 2y minus 2, that will give us minus x plus 1. Obviously we'll be left with minus 1 there, so minus 1 times x gives us minus x, minus 1 times minus 1 gives us plus 1. Just thought I'd do 2 steps in one really. Okay, we want to move everything over. So we move these chaps over, we're going to have 2y plus x, and then of course move the plus 1 over to become minus, and we're left with minus 3. And that's exactly what they want, so they got x plus 2y minus 3 equals 0, and that is 5 marks. Okay, so this is question 6 part B, and we're told that L1 meets C again at Q, and we want to work out these coordinates at Q, and we're told that we need to do this via simultaneous equations. Obviously there's a load of different ways you can use simultaneous equations to tackle this, but what I'm going to do, it doesn't matter which way you do it, but what I'm going to do is I'm going to get two equations that are y equals, and then I'm going to set them equal to each other. So if I rearrange this one, then I'm going to have 2y equals 3 minus x, and then of course y then will be 3 minus x over 2. Okay, so I got two equations for y. I got y equals there, y equals there, so I'm going to set them equal to each other, and I'm going to have 3x squared minus 4x plus 2 is equal to 3 minus x over 2. And of course I want to rearrange this now and simplify it. I got a division by 2 here, so I'm going to multiply everything by 2. And then of course I'm going to move these over then to get a quadratic that I can work with. There we go. Now this quadratic hopefully factorises, which it does, and I'm going to have in there 6x minus 1 and x minus 1 equals 0. And then of course what I'm going to have there is x is a sixth and x equals 1. Now I don't need to worry about the x equals 1 because that was given in the question. We know there's a point P there that's 1, 1. We don't really need to worry about that. Don't have to worry about that. Now what we can do is find the y coordinate for when x is the 6th. And of course we know that y is 3 minus x over 2. So y in this case will be 3 minus 1/6 over 2, which of course will mean that that's 18 over 6, so 17 over 6 over 2. And of course 17 over 6 divided by 2, that will simplify to 17 over 12. Like that. So our coordinates there, our q, will be a 6th and 17 over 12. And that is your final answer. Okay, part C then. So we've got another line L2 has the equation kx plus 2y minus 3 equals 0, where k is a constant. So we want to show that line L2 meets the curve C once only, when k squared minus 16k plus 40 equals 0. So I'm looking at this now, we've got kx plus 2y minus 3, so what we could do is substitute y in for that. So we're going to have kx plus 2 3x squared minus 4x plus 2. And obviously it's quite integral that you use the equation for C. This is the equation for C, hence why I've used this one. And of course if we multiply this out then we have kx plus 6x squared minus 8x plus 4 minus 3 equals 0. So what we've got is 6x squared plus kx minus 8x and plus 1. Now because we want to show that it meets only once, we're effectively going to be using the discriminant. So what we want to do is determine what a, b and c are. Now we've got two coefficients of x, so it would probably be best if I wrote this like that. And then of course, because we know that it meets once, we can say b squared minus 4ac equals 0, like that. And of course in this case b is k minus 8. A is 6 and C is 1. So we can sub these all in. So we're going to have k minus 8 here, all squared, minus 4 times A, which is 6, times 1 is equal to 0. Okay, so k minus 8 all squared will give us k squared minus 16k plus 64, and we're minusing 24. That is equal to 0. Then of course if we simplify this again, we have k squared minus 16k plus 40 equals 0, and that is exactly what we wanted. Okay, part D then. Find the exact values of k for which L2 is a tangent to C. So we're basically going to be finding solutions to what we had in part C. Because you know k squared minus 16k plus 40 is equal to 0. This cannot factorise, so it's up to you. You can either use the quadratic formula or complete the square. I'll just use complete the square for the time being. K minus 8 all squared minus 64 plus 40 is equal to 0. And of course k minus 8 all squared minus 64 plus 40 will give us minus 24. No, and then of course k minus 8 all squared equals 24. And then of course if we square root both sides, then we're going to have k minus 8 equals a plus or negative root of 24. And then simplify even more, move the minus 8 over, we're going to have k equals 8 plus minus root of 24. You can simplify this if you'd like. So think of the highest square number that goes into 24, and that'll be root 4. So we're going to have k equals 8 plus minus the root of, well, if I break it down in just little terms for you, root 4 times root 6. So k will equal 8 plus or minus 2 root 6. And in this case, because it's equal roots, we can say it's equal. I know in previous examples we've always said, you know, draw the graph and get less than or more than, but because this is equal roots, it's going to be equal. So k equals 8 plus minus 2 root 6.